All right, guys, welcome back. Hopefully you had some good work there on numbers 3, 4, and 5. Again, we're on activity 16.1. We're going to be looking at page 225. Just real quick, I wanted to verify some of the stuff you should have picked up in the beginning of this section. I went ahead and listed the 5 properties that we can use to prove that a quadrilateral is a parallelogram. First one, opposite sides are parallel, pretty straightforward. Opposite sides opposite sides are congruent. And so those are the first two. Those ones are pretty straightforward. Then we have one set of opposite sides is congruent and parallel. We have opposite angles are congruent. We don't do that one as much on a graph, but that does work if you can prove the angles are congruent. And then the diagonals bisect each other. So let's talk about how those are useful, how those could be used. So if opposite sides are parallel, how would you prove that? Well, we'd be talking slope formula 4 times, okay? Opposite sides are congruent, we're talking distance formula 4 times, right? So if they ask you to show that, that's what you would have to do. If we're talking opposite side, one set of the opposite sides are congruent and parallel, then you're talking slope twice and distance twice. That's how you would prove it. If they're like, hey, prove this given these 4 coordinates, okay? Or if you're given 4 coordinates, that's the math you would have to do. Opposite angles are congruent. We're not going to deal with coordinates on that one. Generally speaking, you would have to just show the angles are congruent, which we have a proof that's going to do that here in a minute, so hopefully you'll see how that goes. So this one we don't really do on a graph too much, but this last one, this is the magic one if you have 4 points that are on a graph and you're trying to prove it's a parallelogram. This is simply midpoint formula twice. Now, why could we do midpoint formula twice if we're talking about diagonals bisect each other? If you can prove that both diagonals share the same midpoint, then that's going to be where they intersect, right? Because 2 lines only intersect in 1 point, or not at all, or everywhere, so they'd be the same line. So the only thing that works here, really, with the 2 diagonals is if their midpoints are shared, it has to be a parallelogram. So this is the shortest, fastest way, given 4 points on a graph, to find that something is a parallelogram. So hopefully you'll put that in your notes and use that, just a real quick shortcut there for you. So what we're going to do is we're going to skip over to page 225, and we're going to look at try these A. There's an example and some other things before that you're welcome to look through and read in the PDF. Again, we're on page 225. So if you look at 224, there's an example there you can read. But we're going to focus on try these A. This is a pretty long proof. And proofs, just to keep in mind, there is no magic answer. My proof might look slightly different than yours. It doesn't mean yours is wrong. It doesn't mean mine is wrong. It means that we saw it differently, okay? And there might be some steps I leave out. If so, I apologize. It's not on purpose. There's just some little things that I'm not going to stress about too much. Let's kind of talk through what's there and I'll show you what I mean though, okay? So here's our drawing. It's in your book as well on page 225. They give us R, U, T, K, and C, and we're supposed to basically use this drawing and the information they give us to prove that RUCT is a parallelogram. They tell us that RT is equal to RK, and so I'm going to go ahead and make those markings on this graph or on this picture. So they tell us that these two match. Okay, they tell us that RKT, which is going to be this angle right here, that angle right there is equal to angle U. So they're telling me those 2 angles match. And they tell me that angle 1 equals angle 2. So I'm going to put a double angle marker here and a double angle marker here to show myself that those match. I suggest you always do your drawing and that you mark your drawing so you get used to it. All right, so here we go. I'm going to walk you through my proof. I'm going to start with a given statement. All your proofs are almost always going to start with a given statement. My statement is RT is congruent to RK. That's given. Then I say RTK is an isosceles triangle. By definition, an isosceles triangle. Because it's an isosceles triangle, I can say that these 2 bottom angles or base angles are going to match each other. And that is because of the isosceles triangle theorem. All right, so I have those 2 angles equal to each other. And then I'm going to use transitive property to say that RKT, this one down here, RTK, sorry, RKT is congruent to angle U. That's a given. Getting ahead of myself there. So you got to write my given here so that when I write the statement RTK is congruent to angle U, I have the stuff for the transitive property, okay? Transitive property, remember, if A equals B and B equals C, then A equals C, all right? And to show you that, this would be basically like this is A, and this is B, and this is B, and this is C. And therefore, A is equal to C. So hopefully you can see that. Now we're going to focus on these other 2 angles. My focus here is going to be getting my opposite angles of my parallelogram to be equal to each other. So angle 1 plus angle TRU is equal to 180 degrees. TRU is going to be this big angle right here. Equal 90, definition of linear pair. Same thing for the bottom, angle 2 plus angle UCT is equal to 180, definition of linear pair. Then I'm going to do subtraction property on both. I've got TRU is equal to 180 minus angle 1, and UCT is equal to 180 minus angle 2. You're welcome to slow this down if you need to. But I'm going to do subtraction property on both. Then I'm going to use my last given statement. Remember this angle 1 equals angle 2. I'm going to put it on there. Why? Because what I'm going to do is I'm going to substitute. In here where I had angle 1, I'm going to put angle 2. Why do I do that? So notice what happens right here. These two lines right here are identical except for the angles they're talking about. What it allows me to do is to say those angles are equal to each other. That's another transitive property idea. I get A equals B, and this one, if you want, maybe C equals B, and so therefore A equals C. All right, so again, transitive property. Now what have I done? Opposite angles are equal, therefore RUCT is a parallelogram. Hopefully that works for you. The last thing I wanted to show you on this video real quick is, given 3 points on a graph, how do we find a fourth point to make that a parallelogram? So in order to do that, I'm going to erase this real quick. We're going to throw it up on the board real quick so you can see it. These are pretty straightforward. My suggestion to help you see it is to graph it. So I'm going to graph my 3 points. My first point I had was A, which is 0, 0. B is 1, 2, 3, 1, 2, 3, 4. Here's B, here's A, and then C is 0, 7. So 1, 2, 3. Here's C. Okay, now there is not one magic answer to this. I want you to see that there are actually 3 different answers that'll work, and I'm okay with any of the 3 points you get. Maybe you have this parallelogram that goes like this. That would be 1 point up here, okay? And you could simply do match the slope to get up there, all right? Maybe you have this parallelogram. So we go here, then we go across here, then we need to go back down, then we go here. Now, this is actually technically going to be the best answer because notice what we asked for. A, B, C, D is a parallelogram. It depends on how you read it. So D is going to be kind of the magic answer that we're looking for here. But there is a third parallelogram that could show up here. And that is if we had, let me see if I have another color real quick. Yeah, we got a green. So if I were to go A to C to B to D, that would give me a different one. So notice kind of a triangle shows up. Again, if we're looking for A, B, C, D, the order of the letters matter. I go from A to B to C to D. So this is the value I'm looking for, okay? And so what I would do is just match this slope. Whatever this slope happened to be, I would match it here and I would get that point, okay? Hope it makes sense, guys. Assignment that I want you to look at, you're gonna do numbers 6, 7, and 8 and come back to me. Thank you.